When sizing steam valves, you use a different formula than what you would use for solving for water. If you're doing a brand new install, you're going to go off your valve schedule in the print. If it's a one-off coil, you can get help from the valve manufacturer. They certainly know how to size the valves and what you need for your application. You just need to let them know how many pounds per hour of steam is this coil using and what's your design inlet pressure. The other thing when you're reading about this is you're going to hear this term called critical pressure drop or choke flow. If you look this up, all that means is that's at the point where more pressure drop across a valve body is not going to create any more flow across that valve body. With steam, that's considered to be 42% of the absolute inlet pressure, which that means gauge pressure of the inlet to the valve plus 14.7 atmospheric. And 42% of that is considered choke flow or critical pressure drop. You don't want to get outside of that, or you're not going to get any more flow. With water, too much pressure drop, you're going to create micro bubbles. You can start doing cavitation. It'll start destroying the valve body, piping. There's just other things to keep in mind. With water, we're usually doing 3 to 5 psi drop across the valve, so you're not. That's less critical than like with this steam, for example. If you're doing a 2-position valve, you can just do 10% of the inlet to the system if you really want to size it. Otherwise, you can just go line size. It should be fine. But if you do want to figure out your CV, then you use this formula here. So this is the formula they could be using in the background. So CV is how much flow am I getting across that valve body at a 1 psi pressure drop. Q is quantity in pounds of steam per hour. 3 times H. So H is the pressure drop across a fully open valve, like what's accepted, what do you have that's what you're shooting for, times your pressure outlet. So to figure these terms out, you're going to end up solving for this P1, which doesn't show that in the formula. But we'll walk through that. All it is that's your absolute inlet pressure, so gauge pressure plus 14.7 atmospheric. So H is our one piece that we're trying to solve for. That's what we're saying that our allotted pressure drop for this valve. So for 2-position, we use 0.1 because 0.1 is 10% times our example here, 15 psi. Inlet gauge pressure would be that you want a valve pressure drop of 1.5. P1 is your absolute inlet pressure inlet, so that'd be 15 psi because that's what your inlet pressure is, plus 14.7. You end up with 29.7. So your pressure outlet is just your absolute inlet minus your valve pressure drop that you were accepting, that you're okay with, 1.5. So that ends up being 28.2 for PO. So CV equals 1,000 pounds an hour of steam, for our example, divided by 3 times the square root of 1.5 times 28.2. Then you go down through the formula, 1,000 divided by 3 times 6.5, 1,000 divided by 19.51, and you end up with an ultimate CV that you are wanting at 51.25. If you're between valves, say you have a 45 CV valve you can get, or a 55, you go with this valve size up. If it's a 1/3 application or 2/3 application, well, then you take this total CV and 1/3 of it would be sized for one valve and then 2/3 would be sized for another valve. Again, 2-position, you're just going to go line size. If you do want to do a pressure drop, you figure 10% of your inlet, and this should cover high and low pressure steam. If you go down to the modulating, H changes. So everything else is the same. Formula looks exact same. But the way you solve for H is different. So H, again, is a pressure drop across a fully open valve, but modulating under 15 psi, so low pressure steam, needs to be 80% of the inlet gauge pressure. So H, in this application, if we use that same inlet gauge pressure of 15 psi, and we have our same quantity of steam at 1,000 pounds per hour, if we want this to be a modulating valve, we need to take 0.8 times 15, which ends up being 12. The rest of the formula ends up being the exact same. But if you look at what you need for a CV, so instead of Up here, we said 51.25. If you want a modulating valve, that CV goes clear down to 22.87. You do the same thing. You need to size up if you're in between valve sizes, and if it's a 1/3, 2/3 application, then you just take your CV, you use 1/3 of that towards a valve, and then 2/3 towards another valve. High pressure steam complicates it just a little bit more. It's the exact same formula, but H is solved for differently. So this is where you come with this critical pressure drop. So the critical pressure drop is gauge pressure plus 14.7 atmospheric, and then you multiply that by 0.42, which is 42% of the inlet absolute pressure. So now we still want the same quantity of steam per hour, 1,000 pounds per hour, but now we have 40 psi steam. So H is solved for differently. So 0.42 times 40 psi, so that's our inlet, plus our 14.7 atmospheric, because this is absolute. This ends up being 22.974. It's basically the same thing you're doing with P1. This section right here, you're just taking the 40 psi plus 14.7, so that's where you end up with this 54.7. Up here, we would have took that 54.7 times 0.42 to end up with that 22.974. PO, so your outlet pressure is going to be the absolute inlet minus your pressure drop. So the minus 22.974 is 31.726. So you go down through this formula, and now you need a CV rating of 12.35. If you start dropping more than 2 pipe sizes, then you got to figure in a corrected CV. Valve manufacturers, they'll have tables, or they're going to have a way to calculate that. So if you're going from, say, 6-inch pipe to 2-inch pipe, you got to figure in a corrected CV. If you're going down 1 or 2 pipe sizes, this is less of a concern. This is the exact same formula, it's just set up differently. But what corrected CV is, it's just a percentage of your CV that is still part of it, because you did such a reduction in piping from the piping down to the valve. So instead of being 100% of that CV, it might be 0.9 times your CV to end up with that corrected CV. We'll go over that in another video.